Yes, this is the trace PFAS. It's a positive pressure system. There is no use of vacuum, as sometimes there is in the other FMS automated solid phase extraction systems. First, we have the control module here that has a memory card that can be programmed for all the automated steps that we're doing. And then in this case, we have 3 simple processing modules. Each simple processing module has 2 positions to run samples. You can see the cartridges here. So there is a total of 6 samples that you can run with this particular system in parallel. Here we have the cartridges. You can see them here that I've already put in place with a cartridge adapter. These are the sample bottles here, and these are the automated rinse bottles. The whole system is automated, every step, including all the conditioning steps of the cartridge, the sample loading, the drying with nitrogen, the different elution steps, and the collection. So it's pretty much unattended after you start the process. Here we have the pump heads, on also 2 per module. We have the pressure gauges here for the pump. If the pump is on and it is pumping, you will see this, these indicators go up and down a little bit as a sign that the system is operating. And here we have the nitrogen pressures. They're all at about, I think, like 16 psi or something like that. The nitrogen hookup is at the back. At the back of the system, there is also a hookup for aqueous waste collection. After you load the sample from the sample bottle through the cartridge, the water goes to waste that is at the back underneath of the system. We also have organic waste. We can show you that in a moment when we go to the side of the system. You have regulators here for the nitrogen and for the pump. Usually we don't use those much. Shouldn't really be necessary to tweak those around much. Any kind of pressure for nitrogen, as it is here, anywhere between around 15 to 18 psi should be okay. Here we have all the connections from the column, which is the cartridge, and the sample bottle is here. You can see here the yellow line going from the loading bottle, from the sample rinse bottle to the sample bottle, and each of the sample bottles is connected with a black line and a red line. The black line is for nitrogen push, and the red line is for automated sample rinse bottle loading. So there are steps in the program where water and or methanol is loaded into the sample, into the rinse bottle, and through the red line, and then the black line of nitrogen will push when that step comes on the rinse solvent through the yellow line into the sample bottle, and then after that the rinse is loaded here. And this blue line here is also used initially for the sample loading step. So each sample bottle each rinse bottle has 3 lines connected from it, one for nitrogen, one for filling up with rinse solvent, and one to push the rinse solvent into the sample bottle for the automated bottle rinse. So we have discussed the gauges here and the rinse bottles and sample bottles and their cartridges. The pumps are switched on by having this here pointing upward. This is the off position. This is the on position for each of the 6 individual channels, and it needs to be enabled. There is also a reset button if there is an issue with the system, maybe a valve will get stuck, which happens very rarely, but you know, it sometimes does happen. Or if there's anything else going on, it will set off an alarm, and you can deactivate the alarm by pushing this. We have individual displays for each of the modules with all the plumbing, as we call it, the plumbing diagram, which is all the solvent lines and the cartridges, etc., and the nitrogen. So each step of the pre-programmed program that it is going through, you will see the different pathways light up, so you can always tell what exactly is going on within the system from this plumbing diagram here for each step. Here on the right we have fraction lines. I'll go and stand here now. You can collect up to up to 3 fractions for each of the individual channels. The PFAS program that we're doing here, we just collected 1 fraction. So there is only 1 line going from each of the each of the sample line here going to the evaporator. There's also a feature with this system where you can turn on the evaporator automatically in the program. And as you can see also, there's color coding here. Red is 1, and then all different colors, the fraction collected from channel 1, so that would be here, up to channel 6, which is the yellow line here. It is important to know that very low in natural native PFAS concentration. They're all polypropylene, polyethylene tubing on this system, so the carryover of native PFAS from the system into the sample and also into the fractions collected should be very, very low, for basic purposes, almost negligible. Then I think we have pretty much discussed all this here. I will go to the other side here. So here we have the different solvents. We have water here. Close this up. Solvent number 1 is, which here we have with red, also red lines, is methanol. Solvent number 2 is water, and solvent number 3 is isopropyl alcohol. And this here is the organic waste that we collect during the different conditioning steps of either of the bypasses or of the cartridges. Obviously, if you're going to have the sample loading step, you want to go change the polarity of the cartridge methanol and water to go through the right polarity for collecting all the PFAS in the cartridge, and so we end with water with cartridge conditioning. And since our samples are typically in water, this system is used especially for drinking water mostly. There are some other applications too, but that is the main method that it is used for pretty much around the world. So that is pretty much, I think, all the solvents. 4 and 5 aren't hooked up because we're only using methanol, deionized water, and isopropyl alcohol. Then I'll now go to the front of the system to show you the programming attributes. So here we have the, if you turn on the system here with the switch here, this is the top screen you'll see. It has run, editor, configure, and calibrate. Editor, you can edit the different programs. I'm going to press that here. Here you have a list of the programs. You can see typically It's only a limited set of programs that are used by a lot of customers. In this case, the customer here just has a wash program and a actual method, and then some testing programs which test the valves in different configurations. These testing programs are just basically to look at the electronics of the system. It's not meant as a wash or a sample collection program. You can create your own program here by typing with this keyboard a name in and create, and then it would show up here. And the extension for this system of every file is .eco. I'll now select the program that we're going to run. Here you have again the different valving that is also corresponds to the names of the valves on the display here. If you want to make your own program, the different solvents can be checked, 1, 2, and 3, and the different the cartridge, etc., friction, aqueous waste, organic waste, bypass, nitrogen, the rinse. So all those steps that are typically in programs can be done there. We have a save function here. If I go to save, you can do save as under a different name or save, it'll overwrite the existing program. There's an edit button here where you can, if you have a step in a program, you can check the flow, you can check the volume or the time that you want to do the step, and you can also add a description here that you can type in here, and you hit apply all and exit, and then it goes back to the program. A lot of this is all described, or everything actually is described in the user manual. Copy and delete also here. You can add a line by hitting copy. Basically, if you want to create a whole new program, typically we will just use an existing program, save it under a different name, and then go through the different lines to delete most of it, and then you can just change it the way around you, the way you want to. And with copy, you can just copy a line. It will add the same line to the wherever it is highlighted. Say I highlight it here and I do copy. It will add one line under step 8, and you can edit it, and you can also delete. Okay, if I want to run a program, there we have also calibrate and configuration. I'll go through that quickly. The maximum pressure you can fill out here for when the alarm is going off. As I said, it can be that sometimes you have a valve that's stuck, or you may have a bad cartridge and there is no flow through the cartridge. Once it hits 30 psi, it will start beeping. You can program this step here, and you can also program the LCD timeout. It's now set for 17 minutes. You can set it, I think, up to 90 or 120 minutes if you don't want the screen to go black while you're running the program. There are also some other issues that you can check here, reboot and pump head, but that is almost never necessary, so I will not go through that here. Then we have calibrate. You can calibrate the volume and the pressure with these two functions here, and I'll refer to the user manual also. We calibrate the pressure. I very rarely myself calibrate. You can calibrate the pump of each of the positions just using a timer and a graduated cylinder. See how much you collect in, say, a minute or whatever, and you can program that in here, and that's how that is done. Okay, I'm now going to hit run. The program that I had selected, which in this case is called Eco EPA and the date. I'm going to start it now. I think the total is something like 46 or 48 steps in the program. Each country, of course, has its own regulations. In the United States, a lot of people use EPA methods or state methods, depending on what they want to do and what their requirements are. Make their own methods. This all depends on what local regulation or national regulation you are bound by. I'm now going to. I'll show you how to start it. Single means it just runs one single line and it stops. Offset is the whole program starting when it's highlighted. Say I highlighted it at 5 or 4 in this case, and I would press offset. Then it would run the program from step 4 through the end of the whole program, which is like I think step 48 or 47. You can also hold it if you need to. It will just stop the system, and if you press hold again, it will just continue from wherever it left off. And then stop is simply stops the entire program. There is also a cycle here. You can run in cycles. You can, if you really want to automate it to the extent that you want to run multiple times the same program multiple times, you can put a number in here. But I think it's very rarely that people do that. But that option is available. Okay, I'm going to start now. On step 1, I'm going to hit offset, and then we'll start running the program. So we're now at step 8, which is the sample loading step. You can see that the cartridges here are dripping. The water is being loaded across the cartridge, and the levels of water in the sample bottles is going down gradually. One thing I hadn't mentioned is I mentioned the enable here. You can have those up or down. Up means the individual channel is active. Here you also have the valve and the pump switches. There's only 2 positions here, on and off. What you can do if you say you want to run one sample on each of the 3 channels for whatever reason, you can just switch channel 2 and 4 and 6 off. And channels 1, 3, and 5 will be active then, and these the valves and the pumps will be in up position, and that way you can basically run any permutation you want of the 6 channels with these switches. Just wanted to add that. So we are now going to wait till the sample loading is done. So the sample loading is done now, and now we are going to rinse the sample bottle twice, actually once, but with 2 rinses. Right now it is loading the second rinse. You can see that it is dripping into the rinse bottles, the water. And after that it'll automatically rinse the walls of the sample bottle. See here that the water is being pushed by the nitrogen along the walls of the sample bottle. And now it's closing the rinse pathway now. It is going to load the water rinse from the sample bottle onto the cartridge. And you can see now that the cartridges are dripping now, while the sample bottle rinse, the water rinse, is being loaded. So after the loading of the bottle rinses, I now drying the cartridge for 10 minutes. 10 minutes with nitrogen, gas, and you can hear the flow of the nitrogen going through the aqueous waste there behind the instrument. And so this is to make sure that all the water is effectively removed from the cartridges. Right now we are going to load the first methanol rinse into the automated automated rinse bottles. You can see that it's starting to drip into each of the rinse bottles, and after that we're going to rinse the sample bottles with methanol. Right now it's just pushing some air through solvent number 5, and solvent number 5 is not connected, so it's just pulling air through the lines to make sure that all the designated methanol is being transferred into the rinse bottles. So the idea with all these rinses is both the rinse of the water and the methanol, that all the PFAS that is remaining on the walls of the 6 sample bottles is transferred onto the cartridge so that it can be eluted and collected. We're now blowing some nitrogen through the different bypasses. And then we'll get to step 27, which will be the rinse with the methanol. And now we are going to load the methanol from the sample bottles across the cartridge, and this is the first collection step. As you can see here, it's going to the fraction on each of the 3 modules. All the 6 sample extracts are now being collected in methanol. So we use the methanol not only to transfer the PFAS onto the cartridges, but also for the actual elution into the collection vessels. What we're now doing is called make ahead. We are having a little bit of methanol on top of the cartridge so that it can soak, while some of the other steps are being completed afterwards. And the soaking is also done in the second round of methanol loading and rinsing and collection. So we are now getting towards the end of the procedure. We have done the second rinse of the sample bottles with methanol, and we have loaded the methanol and eluted it, and now we are doing it again for the second time to make ahead, and we're going to soak for 2.5 minutes so that the cartridge can be opened up a little bit more with the methanol, and any remaining PFAS that is in the cartridge will be released and can be flushed into the collection vessels. And we're now eluting the remainder of the methanol in the cartridge or in the fraction lines into the collection vessels. And after that, we'll also blow out the lines with nitrogen to make sure that everything has been transferred into the collection vessels. So now we are at step 45, which is the blowout of the fraction lines. You can hear the hissing of the nitrogen gas, and this should effectively transfer anything that is left in the fraction lines into the collection vessels. This step, in this case, is about 1.5 minutes. At the end of the program, there is a step to wash some of the system with isopropyl alcohol. We also have the separate wash program, which we always run without the cartridges. So that is more effective than this last step of the program. So it's sort of optional, basically, whether you want to do that last washing step here or not. But we strongly advise you to always run the washing program in between the regular extraction program. Okay, I'm going to end it now and stop. I'm going to look at the extracts.